Alright, in this video we're going to look at the graphs of tangent and cotangent functions, and then in the next one we'll take a look at secant and cosecant. So we're going to look at finding the amplitude, period, phase shift, and vertical shift of the tangent and cotangent graphs. So recall that tangent is opposite over adjacent, or the y-coordinate over the x-coordinate. And since our x and y coordinates can be positive, negative, or zero, the graphs of tangent and cotangent functions pose some interesting behavior, in particular for tangent when the x-coordinate is 0 and we get a 0 in this denominator here. So what happens at those values where our denominator equals 0 for our tangent and our cotangent graphs as well is we have what's known as a vertical asymptote. And a vertical asymptote is going to be a vertical line that the graph is going to get infinitely close to, but never actually cross or never actually intersect. So it's like that annoying younger sibling that says, I'm not touching you, I'm not touching you. And, you know, the graph is getting really, really close to that vertical asymptote, and it's never actually touching it, but the vertical asymptote has that behavior where it'll get infinitely close, but never actually cross. So here we have the graph in blue of the tangent of x, and notice at negative 90 degrees, positive 90 degrees, 270 degrees, we have these vertical asymptotes. Would work the same for radians, negative pi over 2 radians, pi over 2 radians, 3 pi over 2 radians as well. We have vertical asymptotes where as the graph, as our x values get closer and closer to 90 degrees, coming in from the right or from the left hand side, our y values are going to skyrocket up towards infinity. And as we get closer to 90 degrees for our x values coming in from the right hand side, our y values are going to plummet down towards negative infinity. So every odd, multiple of 90 degrees, so 90 and then 90 times 3 is 270. 90 times 5 would be 450 degrees would be another, as well as the negative angles as well. For tangent graphs, you're going to have these vertical asymptotes. Cotangent graphs, very similar. Notice the cotangent graph is going the other way, though. With cotangent and tangent graphs, I kind of liken them to like half of a double helix, so a helix in, let's say, a DNA sequence. So for cotangent graphs, we have vertical asymptotes at 0 degrees or 0 radians, 180 degrees or pi radians, 360 degrees or 2 pi radians. So we have them every 180 degrees or every pi radians. With cotangent, we're going to have these vertical asymptotes. So looking at the graphs of tangent and cotangent, they don't stop going up or down. In fact, the closer they get to the vertical asymptote, the either higher up they go or the further down they go. So because they don't ever stop going up or down, they're not going to have a maximum point and they're not going to have a minimum point either. So tangent and cotangent won't have a maximum nor will they have a minimum. So they have no amplitude. And as far as the number out in front of the function, like we saw with sine and cosine, it still will perform a vertical stretch or a vertical compression, or maybe even reflected over the x-axis. But there is no amplitude for tangent and cotangent because they have no maximum point and they have no minimum point, so they have no amplitude. For the period, with sine and cosine, we saw that period for sine and cosine was 360 degrees or 2 pi radians. Tangent and cotangent get a full cycle of their graph in between the asymptotes. So if we go back to our graph, notice for cotangent we get a full cycle in between these asymptotes, and that distance between asymptotes is 180 degrees. For tangent, it's also 180 degrees. We could take 270 minus 90. 180 degrees or pi radians if we're in radian mode. So each of the graphs, the period is 180 degrees or pi radians. And so like the graphs of sine and cosine, multiplying your inputs, your x values, by a positive value other than 1 is going to affect the period of the graphs for tangent and cotangent. So instead of dividing 360 or 2 pi by that value like we did for sine and cosine, with tangent and cotangent, we're only going to divide 180 degrees or pi. So that's another key difference between tangent and cotangent versus sine and cosine. With tangent and cotangent, we divide by, we divide 180 degrees or pi by the number that we're multiplying our inputs by. For phase shifts and vertical shifts, they follow the same procedures as that for sine and cosine. So there's no news on the phase shift and vertical shift front for tangent and cotangent. Same thing you did for sine and cosine. All right, so example 1, we have the amplitude, period, phase shift, and vertical shift. So we have y equals 2 times the tangent of, in parentheses, x minus 45 degrees. There is no amplitude, even though there's a 2 out in front that's going to stretch the graph vertically, but still no maximum, no minimum, so hence no amplitude. And that's going to be a common theme throughout the examples in this video. The period is 180 degrees divided by 180 degrees, or if we're in radians, pi radians. Phase shift, we look at x minus 45 and set it equal to 0 and solve it, we get x equals 45. So it's 45 degree shift to the right. And vertical shift, since we're not adding or subtracting anything outside of our function, it's 0, or we could also say none. All right, part B, we have y equals negative 1/3 cotangent of x and then plus 1. Notice the x plus 1 is not contained completely inside parentheses. So no amplitude here, even though it was a negative 1/3 that we're multiplying by. So reflection over the x-axis and a vertical compression by a factor of 3. Period, 180 degrees divided by, well, the coefficient of x is 1, so 180 degrees divided by 1 is 180 degrees, or if we're in radians, pi radians. Phase shift, there is none or 0, since, again, notice that the plus 1 is not in parentheses. So the plus 1 is actually a vertical shift going up 1 units. Example C, 1.5 times the tangent of 2x plus 120 degrees, and then outside the parentheses, minus 5. No amplitude again. Period, this time 180 degrees divided by this 2 that's in front of the x. 180 degrees divided by 2 is 90 degrees, so we get a full shift with 90 degrees, or a full cycle rather. Speaking of shifts, phase shift, we can set 2x plus 20 equal to 0. So subtract 120 from both sides. We get 2x is negative 120. Then divide both sides by 2. We get x is negative 60. So we have a phase shift going 60 degrees to the left. And then finally, the minus 5 that's outside the function here. The minus 5 is the vertical shift down 5 units. All right, that about does it for this video. In the next video, we'll take a look at the graphs of secant and cosecant. So I'll see.